Alright, this is Geometry, Chapter 8, Section 3, Intro into some basic trig. Um, uh, Trigonomic ratios. Trigonometric ratios. Trig meaning triangles. Measure, right? Geometry measure of ratios, fractions, basically. So when we talk about trigonometric or trig ratios, everything stems from the base, which is a right triangle. Right triangle. Remember, a right triangle is a triangle with a 90-degree angle. The side opposite of the 90-degree angle, we're going to call that C. We're going to say lowercase c. And then the angle we're going to call uppercase c. Then we have angle A. And the side opposite of angle A, we're going to call lowercase a. And then we have angle B, uppercase B. And the side opposite of that, we have a lowercase b. Okay? Now, there's going to be a phrase that you're going to see quite a bit that will help you with trigonometric ratio, and it's something called SOHCAHTOA. We're going to get to that in a second. No, that's not what I wanted. All right. When we talk about trigonometric or trig ratios, we're talking about three types of fractions. Really six, but three for this course. And the first one we're going to talk about is the one called sine. And the way that we do it is shorthand for sine is sin. We have angle A. So the ratio of the sine with respect to angle A is equal to opposite over hypotenuse. Opposite over hypotenuse. In this case, what is opposite of A? Lowercase a. So opposite over hypotenuse. Remember, this is the ratio. So you have lowercase a. What's the hypotenuse? Lowercase c. So this is the ratio. This is the fraction of sine, opposite over hypotenuse. And this is where the SO comes from SOHCAHTOA. Sine is equal to opposite over hypotenuse. So for SOHCAHTOA, opposite over hypotenuse. And that gives us my ratio. And this is the ratio of the side that's opposite of A over the hypotenuse, which is opposite of C. Sine. So opposite over hypotenuse. Then we have the CA. Hopefully you're starting to see a pattern. CA means, the C part means cosine, or the complement of sine. Cosine. And we write it with three letters, cos, or co. And it's going to be cosine of angle, we'll use angle A again. Cosine of angle A. And If O was for opposite, we'll use A, and that's going to be adjacent. And adjacent is always the guy that touches angle A that's not the hypotenuse. And it's going to be adjacent, and H is also for hypotenuse. Cosine is adjacent over hypotenuse. So what's adjacent to angle A? What touches angle A? B. Lowercase b. What's the hypotenuse? Lowercase c. So the cosine of angle A, that ratio, is going to be b over c. And then we have the last one, TOA. Oh shoot. Oh shucks. TOA. And TOA, the T part stands for tangent. And that's going to be tan, short for tangent, of angle A equals, now we know what O is now, opposite, and we know what A is now, adjacent. And this is all with respect to angle A. We also have one, there's also sine, cosine, and tangent for B, and that's something totally different, but it's similar, and I'll get to that in a second too. Tangent of A is equal to opposite over adjacent. So opposite over adjacent, that is going to be opposite of angle A is lowercase a. Adjacent to angle B, AA rather, is lowercase b. And remember, the reason why it's not C, because C also touches A, the reason why it's not C is because C is the hypotenuse. So it's going to be whatever touches A that's not the hypotenuse, that is adjacent. Whatever touches A that's not the hypotenuse, that is called the adjacent side. So this side. So trigonometric or trig ratios are the ratios or the fractions of the sides of a triangle with respect to a given angle. Okay, with respect to a given angle. Now, to evaluate these bad boys is pretty straightforward. So, kind of want to point something out. So we have 90 degrees, that's R. Opposite of R, that's 17. We have a gira, that's 8. G to R is 8, and then from R to T is 15. Okay, right triangle. So they want to know what sine, cosine, and tangent are. So remember, we'll use SOHCAHTOA. And they're asking for G. So here is angle G, only with respect to G. So if we want to find sine of G, so opposite over hypotenuse, opposite of angle G is 15. Hypotenuse is always going to be opposite of 90 degrees, that's going to be 17. So 15/17. If you can, simplify the fraction. If not, we keep it as a fraction. No decimals. I repeat, no decimals. Decimals. Alright, cosine of G. The cosine is adjacent over hypotenuse, So adjacent over the hypotenuse. So I look at G, and I look at the side that touches. Remember, adjacent is the side that touches G. That's not the hypotenuse. 17 is the hypotenuse. We don't use that. We use the adjacent side, which is in this case 8. And it's going to be 8 over the hypotenuse, which is 17. Simplify if you can. I cannot hear, so it's 8/17. Then we have the tangent. Tangent of G. And the tangent of G, TOA, opposite over adjacent. So opposite over adjacent. Opposite of G is 15. Adjacent to G, that's not the hypotenuse, is 8. So 15/8. Here's what I want you to recognize. So we have this angle T, and the book did those guys for you. Notice that I'm going to look at sine T. I'll put it black. Actually, no, I'll put it in blue. Sine T, they have it for us is 15/17. Oh, I'm sorry. 8/17. Alright, notice that the sine of T is the same thing as the cosine of G. Let's do the cosine of T. Here's T, adjacent over hypotenuse. That's 17/15. Cosine of T is the same thing as sine of G. And then we have tangent of T, which is 8/15. And tangent of T is the inverse, reciprocal. Right? It's the inverse of tangent of G. So sine of G is the same thing as cosine of T. Sine of T is the same thing as cosine of G. They have these relationships with each other. So keep that in mind. Oh, blurry. For parts, blah, 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 find the value of W to the nearest 10th. Okay. So we have for A, they give us this triangle. We have a 54 degrees. We have 17, and we have W. Alright, I need you guys to make sure that your calculators are on degrees. Like degrees. We have the hypotenuse, right, because it's opposite of 90 degrees, and we have W. This W is opposite of 54, so we can use sine. And we have this angle here that's 54 degrees. So to set this up, we have sine of 54 degrees is equal to, remember it's SOHCAHTOA, so opposite over hypotenuse, so W over 17. We're solving for W, so I'm going to multiply both sides by 17. When I do on one side, I do to the other. That cancels. So I have that W is equal to 17 times sine of 45. So the way that you do this in your calculator is you hit the sine key and you put in 45. That's going to give you some decimal. And then multiply that times 17. That gives me that W is equal to 12.02. So this side is 12.02. Okay. For B, we have another right triangle. This guy is 1. This guy is 28 degrees. This guy is W. So I don't have the hypotenuse. I have this guy that's opposite. I have this guy that's adjacent to 28. So I'm going to use tangent. And remember, tangent is TOA. So opposite over adjacent. So tangent of 28 degrees is equal to opposite, which is 1, over adjacent, which is W. I'm going to multiply both sides by W. And I get W times tangent of 28 equals 1. Then I'm going to divide both sides by tangent of 28. So when I set this up, it's going to be 1 divided by, and then put in parentheses, tangent of 28. And that gives me 1.88. 1.88. And I feel good about that because that should be bigger than 1. But it should be less than this guy. Alright, good. Then, we have another one. We have a W, we have a 33, and we have 4.5. This 4.5 is the hypotenuse. Oh, this 4.5 is the hypotenuse. There's the hypotenuse, and then we have this guy which is adjacent to 33. So this looks like a cosine situation to me. So cosine, remember cos adjacent over hypotenuse, so cosine of 33 degrees is equal to adjacent, which is W, over hypotenuse, which is 4.5. So I'm going to multiply both sides by 4.5. And I get 4.5 cosine of 35 equals W. And this guy's cancel right here. So cosine of 33. I don't know. That'd be bad if I did 35. Alright, so cosine of 33 times 4.5, and that gives me 3.77. And I feel good about that because the hypotenuse has to be the biggest number. So since W is 3.77, I feel confident in that answer. Okay. Intersection of some street, Filbert Street in San Francisco, rises at an angle. If you walk up 150 up in the section, what is your vertical rise? Alright, so we have thing here, we have something here, and we have this here. This is 17 degrees. This guy is 150. They want to know what my vertical rise is, so R for rise. Alright, I have a hypotenuse. This guy is opposite of the 17, so this looks like sine to me, or SOA. Opposite over, I'm sorry, hypotenuse. So sine of 17 equals opposite over hypotenuse. Multiply both sides by 150. So r is equal to 150 times sine of 17. Alright, so sine 17 times 150, and I get that the vertical rise is 43.86 feet. They want to round it to the nearest foot, so that's about 44 feet. Alright, so this is the part where I need you to make sure that you have your calculator set to degrees, and I'll explain how to do that later in life for those who don't know how. Alright, so sine of x is one thing. We did the opposite over hypotenuse. We also have something called the inverses of this guy. So it's written as sine to the negative 1. And the sine to the negative 1 cancels out the sine of x. So if I was to do sine of negative 1 of sine of x, these guys cancel each other out. The sine and the inverse sine cancels each other out, meaning that I'm left with whatever's inside that was touching the cosine. So I'll be left with the x or the angle. So we use inverse of sine, cosine, and tangent. So that's inverse sine. We have inverse of cosine, and we have inverse of tangent, right, of these things. And they cancel each other out. These are the inverses of sine, cosine, and tangent, and we write them as such. So if I wanted to find an angle, we'll figure out the right. What is y to the nearest? Alright, so they give me this guy right here. Actually, I'm going to go through all of those. Let's go through both of these. So we have this triangle here. 6, tan, this be the h, this is b, this is x. Right triangle. We want to know what x is. So here's x. We want to know not the distance of b to x, they want the degree. How many degrees is this angle? We use inverse sine, cosine, tangent to find angles. I have the hypotenuse and I have the side opposite of this. So this is sort of a sine situation. Opposite over adjacent. So if I was to do sine of x, that's going to be equal to opposite over adjacent. 6 over 10. I don't really care about simplifying the fraction. It doesn't really matter. But I know for some people it bothers them. So if you feel the need to simplify and make it 3/5, feel free. Alright. But that doesn't help me, right? That just helped me find the ratio. I want the angle. And what I do is I take the inverse. Of sine. That cancels the sine out. What I do on one side, I have to do to the other. So I'm going to inverse sine on the other side. And when I do that, I have x over here because they cancel out, and I have the inverse sine of that. So in your calculator, the sine, cosine, and tangent buttons also has the inverses. So you would hit second on your calculator, and then sine, which is your inverse sine, and you put in the ratio. 6 divided by 10, and parentheses, and I get 36.8 87 degrees. They got that longer number. Beautiful. Same thing over here. They have another triangle. And this guy is double X, M, N, right triangle, 15 over here, and 20 is the hypotenuse, and they want me to find angle X. How much is this guy? So with relation to X, I have 15, which is adjacent, and I have 20, which is the hypotenuse. So that sounds like a cosine type of situation to me, which is opposite over adjacent. So cosine of X is equal to adjacent over hypotenuse but again, I don't want that, and you can simplify that to 5/4 or 3/4 if you want, but I don't want that. I want the angle. So in order to get the angle, I'm going to inverse cosine. What I do on one side, I do to the other. Inverse cosine and cosine cancels out. That leaves me just the angle, X. And I would press second cosine 15 divided by 20, and it gives me 41.41 degrees. Okay. So for this last one, we have right triangle, we have 100 over here, we have T, we have P, we have Y, and we have 41. We want to know what angle Y is. Alright, well, what do we have in relation to angle Y? We have the adjacent over here, and we have the opposite over here. It sounds like a TOA situation to me. Adjacent over hypotenuse. So tangent of Y is equal to opposite over adjacent. 100 over 41. Alright, remember, in order to get Y, I got an inverse tangent over here. What I do on one side, I do to the other. So I inverse tangent on the other side. This guy goes, I'm just left with Y. And second tangent 100 over 41, and I get 67.71 degrees. Okay, that is that section, I believe. Yep, I hope you have a great rest of your day.